All right, take two. Welcome to subtraction of decimals. So this time I'm going to get it right. Subtraction of decimals is much like subtraction of any other numbers. You've got options for how you solve it. There's just a few things you need to remember. So to reverse, to use tidy numbers, or to compensate are all good strategies for decimals, just like they are with whole numbers. So the problem we have here is if school is 0.8 kilometers away, 0.8 kilometers away, and I run 0.58 kilometers, how much further do I have to run? Now, I've written the problem out three different ways there. 0.8 take away 0.58, and again, and then the last one, 0.58 plus something equals 0.8. So it helps to think about these as being the same as 50 take away 58. And by that, I mean here, it helps if you think of the same number of digits in the problem, the same number of decimal digits, 80, 2 digits, 58, 2 digits. Because often people say, well, 8 take away 58. Well, you can't do that. But this is not 58. This is 58. And it is smaller than just an 8 or 0.8. So the first one I'm going to put in here is tidy numbers. Probably the most popular way to solve a problem like this. I've got 0.8, and I'm going to first of all take away the 0.5 part of it, which gives me 0.3, and then I'm going to take away what's left, which is a 0.08, and this is where you could come up with a problem. I'm going to just pretend like there's the same number of decimals. I'm going to treat it like 3008. In that case, I'm much less likely to make a mistake, and then I know this is 0.3, take away 0.08 is 0.022. Another way you could do this, for some of you, you're quite good at the old compensating, or similar to like equal addition, to solve a subtraction problem. So here I might say 0.8 take away too much. I'm going to take away too many here. I'm going to take away 0.6 and then add the 0.02. And the reason I'm adding that back on is because 0.6 is too much. I didn't want to take away that much. Again, it could help to think about all these numbers having the same number of decimal places, and in which case I would have here equals 0.2 and then plus 0.02 will give me the same answer. The other way, and actually a lot of people would do this, they'd say, well, if I've already run a certain amount, I'm going to work out how much more, 0.58 plus what. And if you really struggle with subtraction with whole numbers, that's not going to change with decimals, but just remember that to reverse the problem can be really effective. And then here it's a matter of just doing place value. So, tidy numbers, 0.58, and I'm going to just tidy that up first so that it's going to be plus 0.02. And then I'm going to add, so that would take me to 0.6. No, just 6. And then on top of that, I would just need to add the 0.2. And I'm just going to come back at this point and just highlight the numbers that are really important to that in terms of adding what has been added. What I added first was 0.2 to get to the tidy number, and then I added 0.2 to get to the 8, or 0.8. So you're going to have a whole lot here, which aren't there yet. But I'm going to be adding a few in there, and what I would like you to do is to also just put in here a bit of a code for which solution, which way you've solved them. So you can put in a T if you're using tidy numbers, put in a C for each one if you're putting in compensation, and an R if you are reversing the problem. They're all going to be worded, so you have to sort of write the equation, and I want you to actually write out the equation. I don't just want to see the answer, and hopefully that's all good. Remember, any strategy will do. They all work, but some are better in certain situations, better than others. And of course, if you're really stuck, if decimals throws you off, just remember, give them all the same number of decimal places. That's all from me, guys. Thanks very much.